Today we're going to talk about geometric terms. And first of all, geometry. What is geometry? Well, informally, it's the branch of mathematics that studies shapes and space. But sometimes it's really helpful when you're learning geometry to kind of break the word apart and look at each. And actually what geo means is earth, and then metry means measure. And the thing is, as we go through these words, you don't have much to fill in, but these are crucial of knowing what they mean to help us as we study geometry throughout the year. So the first definition is a point. It's a location with no sides. Now in a minute we're going to fill in that chart and we'll look at, in general, you draw a little point on the paper. And again, we'll fill in that chart here in the diagram momentarily. And a line is made up an infinite set of points. And it's in a straight path, and it extends in opposite directions. A line segment is just a part of a line. It has a beginning and an ending point. And then finally, a plane has infinitely many points. The letter P isn't very good there. I don't know if it will recognize that word or not. Let's do that. Come on. So points, infinitely many points, and extends on a flat surface in opposite directions without end. Extends on the flat surface that extends. So, how do I think of a plane? I think of it as a piece of paper. And it just extends out. So, it's just a flat piece of paper. Typically, it is in kind of a quadrilateral or a rectangle form. But it's just goes this way and it goes this way. It doesn't go up or down. So it's a flat piece of paper. Oh boy. So if we look at the diagrams here, so a point, like I said a moment ago, is simply a point, a period, maybe, if that works better on the video. We draw a point as a dot. It's called by a capital letter, so I could put in A here. So in this case, this would be point A. And even though we can tangibly see that, technically in geometry, a point has no sides. Don't get caught up in that. Just know what a point is. A line, well, a line looks like a line with two arrows in it. And then typically what happens is we have 2 points that name that line. So we can say like BC here. It's a set of connected points, but again, go back to the definition here for a minute. It's an infinitely many points. We can never count how many points are on that line because it continues on in either direction forever and ever. If we look at a line segment is just going to be a part of a line. So here we can say DE still a set of connected points. The difference is that on DE, we have a starting point and an ending point. So when we look at these two here, when we name a line or a line segment, there's going to be 2 points on it. In terms of the line, this would be line BC with an arrow on top. That's how we signify or show that we're working with a line. If we're talking about a line segment, I tend to draw it like this, just a straight line, no arrows on the end. If you want to get technical, it has a point on either end. I seldom do it. There's no thickness to this. Finally, a plane. Again, plane I think of as a flat surface, honestly. I think of it as a piece of paper. It tends to be drawn something like this. And you have, let's see, F, G, H. Point F in there, point G, point H in there. When you name a plane, we have 3 points, and that's why I put 3 of them in there, and they are not all on the same line. They're not all on the same line. So what we would call this is we would call this plane FGH. I don't have an abbreviation, but sometimes it's a little bit easier because in the corner of this, and we'll see that on our example coming up here in a minute, in the corner there's a letter. And we can also call this like plane A if there's a letter in the corner. Otherwise, we have to identify it with 3 points in there. And again, there's no thickness. So when you think of the plane, we extend out to the right, we extend out to the left, but we can't take that plane and extend it up and down. So if I scoot this here, a little bit more vocabulary here. Collinear means that all of the points are on the same line. And coplanar means that all of the points are in the same plane. And then space is all points and lines in 3 dimensions. So a couple other things to note here. I don't get too caught up in it. I should get more caught up in it than I do. But congruent here in the box is a word, and it means geometrically equal. And segments are congruent, distances are equal. So if we're talking about a segment, then we say that segment AB is congruent, and there's the symbol. It's an equals with a squiggly on top of it. Segment AB is congruent to segment CD. But if we're looking at a length, like how long is segment AB, how long is segment CD, then we use equals. And again, I don't think that the state test gets too caught up in that, which is why I don't get too caught up in there, but I don't want to overlook it. because sometimes you're going to see the congruent symbol and other times you're going to see equal symbol. So we need to be familiar with that. And the hardest part here is in geometry, point and line and plane are considered undefined terms because they're only explained using examples. Like, since a point has no size, how can we really take something that has no size and use it as part of the definition, and a line, which is made of infinite points? So that's the difficulty here. But in general, we need to have a basic idea of these different words. I have to do this. Okay. So here's our first example. Using the figure to name each of the following in two different ways. A line containing the point K. So a line containing the point K, remember that we're going to have a symbol like this on top of it with two arrows on it, and you name a line with 2 points. So it's not limited to one answer. I, on my notes, put JL, but there's 2 other choices. We could have said JK, or we could have said KL. So there's 3 different choices. So you can be sitting beside somebody taking a quiz, and one person has JL and another person has JK, and they're both right. That's the nice thing. When we look at letter B here, a plane containing the point L. Well, here I want to point out that there is a B in the corner of this plane. So we can say plane B, or we can name the plane, but the plane has to be with 3 non-collinear points. So you can't say plane JKL because J, K, and L are all on the same line. But we can say something like plane JML because those 3, J and L, are on the same line, but M isn't. 3 non-collinear points. By the way, we could have also called this line, and I should have done it over here, the line containing point K, we could have said that it was line A. There's a little lowercase letter at the end of that arrow that also indicates the line. Number 2. Name 3 points that are collinear. And take a minute here, and at least in your mind, think of 3 collinear points before I write down my answer. 3 points that are collinear. If you're writing in pen, don't write it down so you don't scribble it out if you accidentally get it wrong. R and T and Q, not using any terminology here. We just want 3 points. We're just representing 3 points that are all collinear. Letter B. Are points P, Q, R, and N coplanar? Well, let's look at where they are. P, Q, P, Q, R, and N. Are they all in the same plane? Yes. They're all in the same plane. Finally, at what point does line PN, so now we're going back to Aiden's terminology here. Here's line PN, starting here, and line QR. Here's line QR, just on the video so you can see what I'm talking about. Where do they intersect? And it looks like they intersect at 20. Right here are where the two lines intersect. So I had to draw a quick picture here because I forgot to scan it in. But if we take a look at this one, what the directions say is that segment DB is a segment bisector. Find the length of BC. So we want to find this length. And we didn't really talk about segment bisector, but bisect means cuts in half. So what we're saying here is that what I'm going to draw in blue here, and it's not very straight, I'm super sorry. That segment is dividing now our black and red line in half. So what we need to do to finish today is that we're going to take 4x minus 5, and we're going to set it equal to 11 plus 2x. And now we're going to use our solving equation skills to finish this problem. So to finish, we're going to undo. I'm going to move my letter to the left, which would be more than likely the way your Algebra 1 teacher taught you. So 4x minus 2x is 2x minus 5 equals 11. Since we moved our letter to the left, we're going to move our number to the right. So we're going to add 5 to both sides. And we get 2x equals 16. And finally, 2 times x. To undo the multiplication, we're going to divide both sides by 2. So we end up with x equals 8. And that's great. We solved the equation, but that's not what we want to know. What we want to know is what does the length of BC equal? So we want to know this red length here. So we want to take 11 plus 2x, and we're going to put the 8 in there. So it's going to be 11 plus 2 times 8. The 8 coming from what we just found. So 11 plus 16 is 27. So our length BC equals 27.